Welcome. Welcome to another edition of NG India, the 6th edition this year, and every edition is great. Every time when I'm here, I try to give a little bit of information, what I did after the conference last year. So here you see a picture from a lot of very nice people and speaker here of the conference, and this is basically the start of our trip from last year. And I'm very happy that we also planned another one for this year. As you know, I love to travel India. Okay, zoneless and reactivity is a long-term passionate topic of mine. Just that you understand what the context of this talk is, let me give you a little bit of history. 18, I finished a pretty in-depth research, long and big research on reactive ephemeral state management. Back then, it was not really well known. Nowadays, everybody knows local state management, right? So that was the research, and back then I called it ephemeral state. 2019, I released the first library in Angular. This was focusing on local state management in components, and also the first one and only one until today that makes it possible to go zoneless, but partially. So you will be able to migrate, not switch a flip, make a big bang refactoring, but do it step by step. 2020, I did elements and zoneless. 2021, I was speaking about fully zoneless applications, how we can reach that already with the recent versions. 2022, gave an in-depth one on partially zoneless applications, and last year on signals. And this all comes together because we need architecture and we need simple architecture. So this talk today is basically starting, I would say, a new era in the way how we write applications. On the agenda, here I will show you 3 different reactive primitives, 3 different functions that you need to compose those reactive primitives. I will show you where the glue code problem lies, like it's a special term, you will see that later, and then how you compose all that stuff. Let me quickly introduce myself. My name is Michael Hladky. Hladky is maybe not the easiest name to read, write, and pronounce here, so you can stick with Michael. I'm on Twitter, not X. I also do a little bit of open source, and this is our company website. We have a couple of services focusing on Angular. Today, I want to talk about the very big picture of front-end applications. And your application lives basically between 2 different edges. The upper edge, this is what I call edge or the closest server, and the lower part is the screen, the pixels that get colored, and your user input devices like a keyboard, a mouse, or anything else that can give input to your computer. And those 2 edges define basically what you need to do in your application. You will receive data and you will send data, you will process the user input, and all of those things are events, right? 95% of the web is event-driven, stateless. If you realized in the past it was already not the easiest to pick the right architecture for your state management, and nowadays I believe it got even worse. We have 4 ways of writing an Angular component, we have this and that many libraries, we have NGRX, for example, has 3 different versions of state management libraries, and I believe it just gets more and more complicated. So what I want to pitch here is less is more. A mindset and concepts that are very easy to grasp, quickly to understand, and quickly to apply on your application. And I will start with the building blocks. 3 different building blocks that you need to understand to write any application in the front-end world, at least nowadays, because we all, like all front-end frameworks, tend to go in a similar direction. So what are the 3 blocks? Events, right? Most important. 95% of the web is event-based. In the middle, you have state, that is basically something that you need to remember while your interactions with the app take place. Maybe you remember that only on the client, maybe you pull it from the server. And then effects. An effect is basically the tail end of your data streams. This is basically the place where pixels get colored or a log is fired and so on and so forth. So let me show you a little bit more in depth what those three principles are. Events is basically, as I told you, nearly everything. Yeah? Every data that you consume from the top, HTTP requests, WebSockets, native APIs from your device, or even browser native APIs. They all live in this event manner, and on the bottom you also have the other end. You have a keyboard, mouse, display, everything that user interactions are coming from. So those are basically events, everything, right? Everything is an event, basically. The second thing is state. And 2019, I guess I already pitched what's important for state management, and it's still the same, it stays the same. It is the lifetime of your state. How long does your state live? Where does your state live? Those are the most critical questions that you should ask yourself. And we have a couple of layers here. We have the app layer, feature layer, component layer, and we even can put something only in a part of a template, right? And then it has a very, very short lifetime. What is an effect? I told you before, effect is the tail end of your data streams. An effect is basically the end and would, in your application, either update pixels on your screen, recolor them in a new color. You can fire console logs, maybe you need them to debug something, and you can also fire data events, like you can send data back to the server. This is also considered as an effect, a side effect. And with those three different principles, with these three different building blocks, you are able to write any application architecture that you need. Very simple to understand, but you need to connect those those three primitives somehow, and therefore I will okay. And you have three different functions that you need to compose those reactive primitives. Here you see all in gray, and I will color them step by step and explain why you need them and for what. The first thing is a reaction, the thing that you do before you, or the thing with which you fire an effect. So a button click is triggered and you react to the button click by console logging the output, by firing an HTTP request, by coloring the pixels into a different color. And I listed most common connections on the right side from the top to the bottom. The most common one is the DOM at the very bottom. So you most probably colored your pixels in the screen based on some interactions, and the other one on the upper end is output, right? Your Angular component could have an output, and this is also triggered through those effects. So that function is called a reaction, or reacting to something. The second primitive function that I want to show you is a derivation. Since state management is a topic in front-end frameworks, also the word derivation of state is a topic. In the last years, I talked a lot how the best way to derive something, what is the worst way to derive something. What I want to point out here is that a derivation is basically timeless, synchronous code, right? I have A, and I turn A into B. Or I have 2, and I multiply it by some value. It always happens synchronously. And you can see that because the lines here are straight, right? No shift in time. Setting and getting a value does not really take some time. That is just a tiny bit what you need. Even more often you need something that has behavior, and you want to apply a behavior to your interactions, to your events. And what you see here is 2 circles that touch the box. Those are click events, for example. And then some time passes, yeah, it shifts to the right, and then you see the output 1 circle. That is basically tracking a double click or anything else, like debouncing inputs, all sorts of asynchronous operations that you want to apply to a data stream. That is the third function, applying behavior. And with these three things, we basically can now try to map those to our primitives and have a fixed set of blocks and functions with which we can compose our applications. On the left side, we deal with events or with state. And as I said, you can apply behavior to the streams, to those changes, or you can derive a new value from them. And on the right side, you have this reaction that triggers a certain side effect. Three functions, three building blocks. That's it. Simple and straightforward. There is another thing. You want to compose your applications with those three primitives, and I can show you a couple of abstract examples on how you can think about it. For example, you have input, you have a WebSocket, an HTTP request that you want to derive. That is an event by definition, right? No HTTP request has an initial value or some bullshit. You apply behavior to those events, and then you basically trigger a side effect. What could it be? Coloring pixels, displaying a list. Next thing, you can derive or basically get the next thing from your state management. This is stuff that definitely has an initial value, right? You can start your list with an empty array. You can have already some text in your input box, and in the end you also display that. Last abstract example is from the user input up to the edge, and you have all sorts of events. You have keyboard input, you have mouse clicks. You take those events, you maybe turn them, change their shape a little bit, and then you turn them into an event and into an effect, and this effect then communicates back to the server. Three things, very simple to combine, and as you can see, there is only these three different blocks, and every block has either one of those three functions in it. That is the architecture with which you can basically craft any size of application. But there is a problem. The problem basically is how clean you can write your architecture, how much code you need to introduce this and that pattern in your app. And maybe from the past you already realized that people don't really like boilerplate, and people don't really like to hack constantly things around, right? In the first talk we saw that it would not make sense to wrap an if-else condition. It makes more sense to have a smarter idea like this directive that sets the flag. So same goes here. I want to show a little bit where this friction comes in, and I want to start with one of my favorite friction points that starts when you use signals. Signals, very fancy new thing in Angular. Last year I explained a little bit how they work under the hood. This year I want to show you what problems they cause, and my most favorite problems of signals is that they cause bad state, bad typing. You always have the state or undefined, the state or something else, because they have to have an initial value. And if you try to solve that and you read a little bit and you try to architect it well, that would be solvable with the null object pattern. Another thing is when you want to connect back user input to your state, right? You manage your list, you have the list of movies, you want to click your favorite movie, save that favorite movie somewhere in your state. Whenever you do that and you don't have just a function call, but something a little bit more smarter, like you debounce the user typing, or you only process 1 click instead of 10 clicks, then you need some asynchronicity on those updates, and then it is very hard to connect them back to the state. So this is another friction point where you will see a lot of hacks in your code base and a lot of other stuff. It all leads to clutter code base and boilerplate code base, and this is what we try to avoid since years. So what could be a solution, or how does the problem look? Those two questions I quickly want to touch until we go on. And in my example, I use this movie list here. I render the list of movies, and when I click one of those cards, I mark it as favorite. And if you would use Angular out of the box as it is today with signals, the audio changed a little bit now, I believe. You see, you need a lot of code, and you need a lot of useless code, and this useless code I call the glue code. Why? Because you need that code to combine those things together. It's not really nice, especially the last one is not really nice. But we are more or less facing those problems on a daily basis. So what I want to pitch is use those 3 reactive primitives and functions and go back to a state where you really have clean code and clean architecture. This is an overview of all the places where this frictionless code would get introduced, where you would have a lot of boilerplate. And I don't want to really walk through all of those things. I just want to point out there is a lot of situations where you could run into those problems. I suggest introducing helpers, snippets, and library to get rid of all of them and just focus on a core set, right? So from 12 to 15, 16 different versions, you just now need to focus on some subset of this. And there are libraries out there. There is RX Angular that really focuses on boiling that down, and there are also newer things like ngx extensions and other stuff that basically focus to reduce the boilerplate, reduce the glue code in your application. In this talk, obviously, I will pitch RX Angular, our solution since many, many years. It didn't change because it is that simple, easy to grasp, and that nice implemented that during all the changes of Angular, the APIs stayed the same. So you still have 4 APIs, set, get, connect, and select. And with those APIs, you basically can get rid of most of the glue in all your applications. If you use it, all the code from before would shrink down to around 20% of it. You can see it a little bit more in detail. You have 3 sections. You basically deal with your events. We call them actions. You have your state, and then you display them. I consume observables, and I put out signals. That's basically also the best architecture you can aim for, having signals as close as possible to the template, and the further away you go, have something that is able to run in events, RxJS, or just plain other JavaScript objects. Definitely the best choice. Good. That's it for today. If you're interested in more of those architectural tricks and tips, we run workshops and other consulting services. You can check them out. You can also star our repository, and you can follow me on Twitter or anywhere else. Thanks for your time, and we can mingle a little bit in the breaks. I'm here for the rest of the day.
So Michael just gave us some great insights into the architecture of modern Angular. Thank you, Michael.